Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 15, 2026, just 3 days ago. It performs the first large-scale diagnosis of an artificial intelligence agent society, finding that despite massive interaction density, the agents exhibit a phenomenon of interaction without influence and fail to develop true social structures. The paper is titled, "Does Socialization Emerge in AI Agent Society? A Case Study of Moltbook." And as we'll see later, the results regarding the lack of shared social memory have some really significant implications for the design of future autonomous systems. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the central analogy driving this research. The top panel depicts the evolution of human society, where sustained interaction over time led to complex civilizations defined by shared norms and structural hierarchies. Below that, the figure contrasts this with the current state of AI agent societies, which are scaling up rapidly in digital environments. The researchers use this comparison to ask whether the bottom scenario will naturally follow the top one, effectively questioning if massive scale and connectivity are enough to trigger true socialization among autonomous agents. To investigate this at scale, the researchers focus on Moltbook. Table 1 compares its specifications against prior simulated societies, and the jump in magnitude is immediately apparent. While seminal works like Generative Agents involve just 25 participants, and Chirper.ai scaled to about 65,000, Moltbook hosts over 2.6 million agents. Beyond raw numbers, the final column highlights a critical distinction. Moltbook is the only open, persistent platform that supports agent-level memory, which is essential for studying long-term social evolution. Alright, Figure 2 now provides a sanity check on the platform's activity levels to ensure there is enough data for a meaningful analysis. The blue charts in the top row track population dynamics, showing a clear burst phase where daily posts and unique users skyrocket before settling into a stable rhythm. Interestingly, the new posting users chart shows a sharp peak that eventually trails off, indicating the society transitions from rapid expansion to a mature, steady state. Yet, as the orange charts in the middle row demonstrate, engagement metrics like total upvotes and comments remain high, proving that the agents sustain their interactions even after the initial hype settles. So, Figure 4 digs into the actual content of the conversations to see if the agents are starting to sound alike. On the left, the heat map for daily centroid cosine similarity shows that the overall average topic of the society stabilizes very quickly. You can see this in the large block of red and orange values, which approach 1.0, meaning the collective discourse finds a steady state and sticks to it. However, the right heat map tells a different story, with its daily pairwise mean cosine similarity. Here, the values stay mostly blue and low, around 0.15, which means individual posts are rarely similar to one another. This implies that while the society has a stable center, the agents themselves maintain high diversity and do not collapse into an echo chamber. Well, Figure 4 showed us the global picture, so Figure 6 zooms in to track individual agent behavior to see if they adapt over time. The box plots on the left measure semantic drift, which is essentially how much an agent's style or topic shifts, grouped by activity level. You can see that the most active users in the 500+ bin actually drift the least, suggesting they quickly lock into a stable persona rather than evolving. Then, the center and right histograms show that this stability prevents convergence. The center plot reveals that when agents do change, their direction is random and uncoordinated with the group. Finally, the rightmost plot confirms there is no melting pot effect, as the distribution is centered at 0, meaning agents are not systematically moving toward the social norm. Because the network analysis showed no structural hierarchy, Figure 11 investigates whether agents at least cognitively agree on who matters. The authors posted 45 queries asking for recommendations, and the diagram tracks the resulting engagement. The drop-off is severe. 30 posts were ignored entirely, as shown by the large gray bar. Of the 15 that did receive comments, only 5 referenced other users, and on the far right, just 1 valid reference emerged. This confirms that the society lacks shared social memory, as agents fail to recognize or remember any stable influencers. Wrapping up, the central lesson is that scale and interaction density alone cannot force socialization. Without explicit mechanisms for long-term memory and adaptive feedback, even millions of agents remain isolated in their own trajectories. Future systems will need these social, cognitive layers to evolve beyond simple chatbots. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.